A dummy variable can be included in regression analysis as a predictor, treating it as if it were actually a numerical variable. This example deals with total charges as the y variable or the dependent variable, length of stay as the first independent variable, and sex as the second independent variable. 1 designates female and 0 designates male. We saw in an earlier example that a single dummy variable, male and female, can be dealt with in Excel, and the result is similar to a t-test. When the dummy variable or the 1,0 variable is included with one or more continuous variables, the t-test analogy is no longer appropriate, but the interpretation of the results still has characteristics which are somewhat different from the characteristics of straight numerical variables. Let's use the tools, data analysis, add in, and look for regression, and OK. And now we'll say that the y input range is total charges, and the x input range is length of stay and sex. We have labels in the first row. The output range will be F1. Now when I hit enter, I get the results of the regression analysis. We've accounted for 92% of the variance in total charges using length of stay and sex. Length of stay has a coefficient of 875, which means that for every additional day of stay, the price goes up by $875. If we look to the right, the p-value is very small, which means that this 875 can be considered as different from 0. The coefficient on sex is 1544. This means that there is a $1,544 difference between males and females in the cost of their stay, and this also is a statistically significant result. But let's look at what this $1,544 actually means if we graph the result using the Excel graphing capabilities. Before we graph the result, let us calculate, and I'm going to insert an extra row here so we'll have a place to do this. We're going to calculate total charges predicted. And total charges predicted will be equal to the length of stay coefficient times length of stay plus the sex coefficient times the 0, 1 variable plus the intercept. And these must be fixed with an F4, so we always operate in those cells. And when I hit enter, I get the first predicted value, $2,768. Now if I copy this all the way down, these are all the predicted values for the total charges. Now let's create a graph that will show how the dummy variable sex influences the result of this analysis. First I'm going to highlight length of stay, then I'm going to hold down Control and highlight both total charges and the predicted value of total charges. Now I'm going to go to the chart wizard and select the XY chart and finish. Here's the chart I've created. I'm going to get rid of some of this stuff. And if we look at this chart, we see the blue dots, which represent the actual data, and we see these pink dots, and what the pink dots represent are the predicted values of y. Looking at the pink dots, if I use the drawing capability of Excel, I can put a line through these pink dots, which I'm doing right now, and I'll put another line through these other pink dots. The line through these pink dots represent the costs, predicted costs for women. The line through these pink dots represents the predicted costs for men. The point of a regression analysis with a single dummy variable and a single continuous variable is that the dummy variable creates not one line but two lines. One line which represents the result for the dummy variable coded 1, and a second line which represents the result for the dummy variable coded 2. And if we look at the graph, and I'll move it up just a little bit, the coefficient on sex was $1,544. The distance between these two lines, the vertical distance between these two lines, is $1,544.